Welcome back. Building on the right-angled triangle, we now face the challenge of creating a symmetric pyramid pattern. This is more work because it requires 3 distinct steps inside our outer loop: printing leading spaces for alignment, printing the pattern elements, and then moving to the next line. 1. Outer loop and space calculation. As always, the outer loop controls the rows. For a pyramid, the number of leading spaces needed decreases with each row. If the total height is 5, the first row needs 4 spaces. The number of spaces is always equal to the total height minus the current row index, -1. 2. Printing the elements. The number of asterisks increases in each row. The number of elements in a symmetric pyramid follows the pattern: 1, 3, 5, 7, and so on. This is equivalent to 2 times the row index I plus 1. We use a second inner loop to print the correct number of elements. Three. Analyzing the flow. When I is 0, we print 4 spaces and 1 asterisk. When I is 1, we print 3 spaces and 3 asterisks. This continuous adjustment between spaces and elements is what creates the perfect centered pyramid shape. To summarize, the pyramid pattern is solved by decoupling the printing process into loops dedicated purely to spaces for alignment and loops dedicated purely to the pattern elements. We created a pyramid. Our next lecture 10:09. Find substrings in a given string. See you there.